देखना। हेलो हेलो स्टूडेंट।
नहीं, आप दिख ही नहीं रहा, आप दिखने से है ना मुझे तो। सर स्क्रीन में नहीं आ रहा है, आप समझ रहे हो, स्क्रीन नहीं आ रहा है, ये जो दिख रहा है मुझे दिखना चाहिए, मुझे नहीं दिख रहा लेकिन।
हाँ मैं चालू करता हूँ। दिख रहा है।
नहीं आ रहा जैसे नहीं। ये चीज यहाँ पे भी आनी चाहिए ना, वो नहीं।
ऐसा आवाज आ रहा है? एक मिनट। हेलो हेलो हेलो। देख आवाज आ रहा है?
कुछ आ ही नहीं रहा है तो क्या होता है?
हेलो 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 स्नेहा। स्नेहा आवाज आ रहा है? हेलो स्नेहा। उधर भी आवाज नहीं आ रहा। हेडफोन हेडसेट हेडसेट तो ब्लूटूथ चालू है ना? हेलो हेलो हेलो। मैं तुझे मैं ऐसा करता हूँ, तू इसमें है ना, मैं तुझे लिंक छोड़ता हूँ। अरे वो आरडी से मिला है ना, उधर ज्वाइन करना, जूम पर ज्वाइन। तू ज्वाइन कर, मैं इधर रहता हूँ। हेलो स्टूडेंट, आवाज आ रहा है? हेलो 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 असीम, स्नेहा, अलीशा, आवाज आ रहा है? कैजत सर आवाज आ रहा है? Yes. हेलो हेलो अलीशा, असीम, अभिषेक,
Yes, sir.
स्नेहा, आवाज आ रहा है?
Yes, sir.
ओके ओके। हो रहा है, ये देख ये देख। हेलो संकेश, हेलो संकेश।
हेलो सर, एम आई ऑडिबल?
हेलो संकेश, आवाज आ रहा है?
यस यस, आपका आवाज आ रहा है मुझे।
एक मिनट, मैं मेरा एक ऑडियो चेक करता हूँ, एक मिनट। मैं तुझे को होस्ट बना रहा हूँ संकेश, देन यू कैन।
ओके।
संकेश, यू आर को होस्ट।
ओके, थैंक यू सर।
संकेश, मेरा आवाज आ रहा है?
हेलो सर, एम आई ऑडिबल?
हेलो संकेश,
हेलो सर, एम आई ऑडिबल?
कैन यू हियर मी?
यस यस, आई कैन हियर यू। कैन यू हियर मी? मेरी मेरी आवाज
ओके,
आ
नो
रही है
प्रॉब्लम।
आपको?
अभी संकेश, मैंने तुझे को होस्ट बनाया है, तू तेरा पीपीटी। यस यस, यू आर ऑडिबल। यस
ओके ओके, थैंक यू
यस यस,
सर।
यू आर।
बिकॉज मेरे लैपटॉप
यस
में
यस
शायद ऑडियो का इशू है, तो मैंने फोन से ऑडियो के लिए ज्वाइन किया
यस यस, संकेश आ रही है।
है। ओके सर, थैंक यू सर।
नो, नो प्रॉब्लम। अभी तेरा पीपीटी देख, विजिबल है क्या? वी विल चेक।
यस। इज माय पीपीटी विजिबल? Is my PPT visible now?
यस,
Thank you, sir.
पीपीटी इज विजिबल।
Thank you, sir. So, should we wait for more people to join? We will start at 2 maybe.
यस यस संकेश, पीपीटी इज
Yes,
विजिबल।
sir. Okay, sir. Thank you, sir.
यस,
Thank you, sir.
पीपीटी इज विजिबल।
Thank you, sir. So, should we wait?
Yes, yes. We will wait for 5 to 10 minutes and then we'll start.
Okay, sir. Hello.
Hello, am I audible?
Yes, sir.
Okay, so everyone is from the physics department, TY Physics.
Yes, sir.
Please don't call me sir. Hello, Lakshman sir.
Hello.
लक्ष्मण सर, गुड इवनिंग सर।
Hello,
लक्ष्मण सर, गुड
Sankesh.
इवनिंग। आवाज आ रहा है? हेलो।
Hello, yes sir, you are audible.
हेलो। हेलो 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 हेलो।
Hello, sir, you are
लक्ष्मण
audible.
सर, आवाज आ रहा है मेरा?
Yes, sir.
डियर स्टूडेंट, प्लीज अनम्यूट। संकेश सर, माय ऑडियो इज क्लियर?
Yes, yes, sir, your audio
माय
is
ऑडियो
very.
इज क्लियर संकेश?
Yes, yes, sir, your audio is very clear.
डियर स्टूडेंट, माय ऑडियो इज क्लियर? सबको आवाज आ रहा है मेरा?
Yes, sir. आ रहा है.
हेलो स्टूडेंट, माय ऑडियो इज क्लियर?
Hello, sir, your audio is very clear. Am I audible? Am I audible? Hello.
Hello, am I audible now?
हेलो, आवाज येतोय? हेलो.
Hello, sir. Hello, Milind sir. Hello.
ओके ओके, नो प्रॉब्लम. लक्ष्मण सर. ओके ओके. संकेश, एक 5 मिनट में वी विल स्टार्ट.
Okay, sir. My is my voice clear? Am I audible?
ओके, थैंक यू. यस यस, यू आर.
Okay. Can I start?
Yes.
Hello, hello, Milind sir. Hello.
संकेश,
Yes, sir.
Welcome.
Should I start now?
Sankesh, can we start within 5 minutes?
Yes, sir. Just let me know, sir, because sometimes if my audio is
Yes,
not audible.
Srishti, Sayyed, Alisha, Pooja, Priya, Nupur, Modika, Lakshman sir, Jivesh, Firdos, Divyanshi, Ayan. Uh, okay. Dear student, welcome. And we will start now. Yes, dear student, today's our title is generally advanced material and that is advancement in semiconductor technology and their impacts on different types of research areas. And today's our speaker is Sankesh Shetty. First, I will give introduction of Sankesh. Sankesh Shetty. He is our student, BSc in physics. Then completed masters from nanoscience and technology, and selected for Eiffel Excellence France Excellence Eiffel Scholarship 2023 for further research. Also won IIT Bombay Research Internship Award for 2022 and 2023. Third rank holder in BSc Physics at University of Mumbai in 2021 and BSc Physics from our college, R.D.National College. Won uh, award in Avishkar Research Convention um, organized by Governor Government of Maharashtra, and project title was Generation of Electricity via Moving Trains. Okay, and dear students, uh, currently he is pursuing highest study in University Technology Detroit, France, which is related to advanced materials. And today he will focus on 2D materials and advancements of different types of semiconductor technology. Also, he will explain what are the different opportunities for our science student, basically physics student. Okay, and now Sanket sir, you can proceed for your topic. Okay,
Uh,
thank you.
Thank you, Milind sir, for your kind words of introduction, and I would like to start my presentation. So,
Sankesh, you can
yes,
proceed
sir.
now.
Am I audible? I hello, Ye- hello, hello.
Yes, sir.
Yes. Thank you, Milind sir, for your kind words of introduction. And I would like to start my presentation today. And before starting my presentation, I would I have
Yes,
kept
yes.
my presentation like very light. Like there are no derivation or formulas, just a story behind the evolution of semiconductor technology and why we need it and how we are progressing forward and what I am currently doing and how my work is bit related to this field. So we'll start with the historical progress in the semiconductor industry. Uh, this is the telephone which Graham Bell he invented, and he wanted to spread the telecommunication network from coast to coast in USA. And he faced one problem that he couldn't amplify the signal from the telephone. So when you are commercializing something, you focus that you have many customers. so your product should be delivered to many customers. But since there was an issue with respect to amplification with this type of phone, so he needed something so that it can amplify the signal and can be distributed uh, to various customers in basically in USA, because he founded his company Bell Laboratories in USA. So there, to expand the telecommunication network, there we needed the invention of vacuum tubes, which was basically started with the intention to amplify the telecommunication signal. And you can see how in 1912, before the vacuum tube, the network was, and after the invention of vacuum tube, you can see the spread of network of the telecommunication, because there are lots of customers now. So, but there was one drawback with respect to this type of vacuum tubes, that they used to get heat very fast, and if they get burned out, then there was a lot of issues to fix those vacuum tubes. And the third thing is they look very bulky and ugly. So we needed something that is a bit compact and works the same with higher efficiency. So the scientist further worked in the same laboratory, the Bell Lab. It is very important. It has played a very important role in forming the telecommunication network. And this is a very famous picture on the left hand side of John Bardeen, Shockley, and Brattain, because these are the three scientists who worked upon and to bring the transistor, the concept of transistor. And you can see, I think in physics lab you all may be using transistors. If it is a yes, you can just say yes maybe.
Yes.
यस, सो आप लोग जिस तरह का ट्रांजिस्टर यूज करते हो वो शायद इन कैटेगरीज में से कोई बिलोंग करता होगा, राइट? हेलो, हेलो.
Yes, sir.
Okay, so this is how your first transistor looked like, and there we realized the potential of using the semiconductor materials like germanium, because initially they
Yes, yes,
started their.
you can.
Sorry, sir. Initially they started their research with silicon, and they ended up with germanium as the best material for this transistor. And progressively uh, uh, tra- these type of transistor were
No,
meant
you
to
can proceed.
replace. Yes, this type of transistor was meant to replace the vacuum tubes, but the thing is, no one was agreeing in USA at that time. But there were two Japanese scientists, and they were very interested in this research of transistors, and they wanted to build something commercially out of this transistor technology, and they brought up the transistor radios that is commercially available. Can you guess which Japanese company is that? It is a very profound Japanese company in semiconductor technology. I hope you all may have used one of the products of that company in any point of your life. Maybe you can guess. Hello. Uh, hello. Am I audible? Hello. Am I audible? Hello. Hello. Uh,
Yes, yes.
Uh, yes.
yes.
So I
I
wanted
wanted
to
to ask.
ask, do you know which Japanese company is that? Like of which I'm talking about? It's
You are
still.
audible.
Can you make a
Sankesh, you are
guess? Like,
audible.
thank you, sir. Thank you. Okay, so uh, it's. Do you have you ever heard about Sony?
Yes, sir.
Yes. So the Sony in 1956 showed a great interest in this invention in
इतना
transistor.
फैसिलिटी है
This invention in transistor, and they ended up with bringing the transistor radios, and eventually the transistor it evolved into BJT, bijunction transistor, something this kind of which you use in your laboratory. There are FET, field junction transistors, and metal oxide semiconductor, MOSFET as well. And you see the evolution started like there we realized the use of semiconductors uh, for uh, uh, for for our electronics application, and later we were more interested in combining all these components into one package like integrated circuit. This is thanks to the advancement of CMOS technology, where we could integrate our diodes, our transistors, our resistors in one pack, and we can manufacture a IC like this. And this is the first Intel chip that they produced in 1971 that was available commercially. And this is a very great achievement because uh, in the next slide, I will show you the, okay, what happened? Just give me a second. My computer is mm, yeah. Yes. So this is Gordon Moore, who is an engineer basically, and he played a very important role in condensing and making a compact type of circuits like this one, in the like this one, the integrated circuits. And there is a very famous law in, I think you may have heard or you may have read about it, that the density of transistor or the number of transistors in the integrated circuits will double every year. So you can see an exponential increase in the number of transistors over years. And this is a very famous statement. And you know why this is very ये statement इनका इसलिए famous है क्योंकि ये एक एक्सपोनेंशियल ग्रोथ को प्रमोट करता है, और एक्सपोनेंशियल ग्रोथ यानी कि एक्सपोनेंशियल प्रॉफिट. सॉरी.
नंबर लेने के लिए सर वो प्रभा जी को फोन कीजिए आप 5000 का नंबर है ना उसका फोन कीजिए वो आपको
हेलो. हेलो.
Yes, sir.
No, like someone is asking question. Uh, okay, so यहाँ तक clear है. Moore's law. This is a very famous law. I hope you have heard about it or maybe read about it. So this is what we are intending to follow the Moore's law to have a exponential profit. But nothing is so easy to achieve the exponential growth, because there are there are some heat effects, there are some electron tunneling effects, as well as the feature size is not so available to have a compact type of circuits. So we have to advance for more other semiconductor materials. So that's why, and these circuits like were famously from silicon and germanium, but we want more other materials as well. So this is where we are right now, where we started from 1960, like 1945, 1960 around, and this is where we are, and this is where what we are targeting, like very transparent kind of sensors, or maybe transparent kind of devices, and this and which has promoted for a global communication around us, and communication has become a very important part. Like I am here in another country and I can communicate with you guys thanks to this technology, to the advancement of these technologies. So, like, let's understand the very basic part of semiconductors. I hope you have learned about it during your sessions, maybe just a glimpse, a quick revise, maybe. So, the materials, they are classified on the basis of their electrical properties, with their low resistivity, termed as conductors, and progressively increasing. There is a semiconductor which lies in the range of 10 raised to minus 5 to 10 raised to 3, and there are insulators which has very high resistivity. Also, the band gap of conductors, they are they are almost like 0 or 0.1 maybe sometimes. And semiconductors, the band gap lie from 0.1 to 4 electron volt, and the insulators, they lie like above 4 electron volt. And this is a energy band diagram. This is how the conduction band and the valence band. The conduction band is the topmost energy level, you can say, where the electrons are almost free in that region. And there is a valence band which is situated just which is just a just a next lower energy level. And the conduction band and valence band are either formed by crystal field splitting, or maybe maybe the combination of by the formation of if you have read about molecular uh, uh, yeah, MOT theory, molecular orbital theory, in which we see there is a formation of sigma star bond. And this is how, like, if the it depends on the type of bond, whether it is covalent, or whether it is ionic bond. And you can see the gap between the valence band and the conduction band is very less in semiconductors. So the electrons in the valence band can easily absorb the energy from the light, or from the thermal energy, maybe sometimes at room temperature. And it can jump on the it can jump in the conduction band. And other way around, the electron which is at the conduction band, where is my cursor? Yeah, the electrons which will be at the conduction band may either jump to the valence band and combine with the holes and form and emit energy. And the energy may be in the form of light if it is radiative type of recombination, or it may be a phonon, that we can understand it as heat, that is non-radiative type of recombination. Now, like this is like very I don't want to go in the details of this, just I want to let you know, depending on the type, the energy difference, we call it as band gap, and depending on the type of recombination of electrons and holes, we term them as direct band gap or indirect band gap. And this is the energy versus momentum diagram. And if the electrons and the holes have the same direction of momentum, then we call it as a direct band gap material. Or for a simple understanding, we can understand that when the electrons and the holes recombine and emit light, it is called radiative recombination, and the material is and the semiconductor has a direct type of band gap. And if the electrons and the holes, their direction of momentum is different, and if they want to recombine, they have to emit energy, maybe in the form of heat, sometimes not in the light, that is non-radiative type of recombination. We call it as direct band gap. So basically we can understand that direct band gap type of semiconductors emit light, and indirect band gap type of semiconductors, they don't emit light. Am I clear?
Yes, sir.
Yes, thank you, thank you. So there is a very strong correlation that has been observed over years, that the amount of light consumption by any country is directly proportional to its progressing GDP. And if you want a very strong proof, or maybe a very something with which I can convince you strongly, then uh, I can show you this. Can you guess, or can you let me know what it is? Anyone can give a try, maybe, or if not, you can just let me know. No, then I can proceed further.
No,
Hello.
sir.
Okay, so this is nothing but the country North Korea and South Korea, and it is a border. We can see the progression in the GDP, maybe of North Korea and South Korea. So this is a this is just to convince you guys that there is a strong correlation between the consumption of light and the GDP produced by any country, maybe. So to the very basic light sources that we have at home in the early, now I think most of the places have LEDs, but earlier we had like incandescent lights and halogen lamps. And the disadvantage of these materials were that they are not so eco-friendly, and they have very high electric consumption. You may have heard people talking about, or since you are students of physics, you may know that this type of bulb usually people avoid to use, because they get a very high electricity bill because of these type of bulbs, maybe. Have you heard about that before?
Yes, sir.
Yes, because I'll let you know why it is so in my just next slide. And this is not so eco-friendly because it produces a lot of heat, and much of the energy it produces is wasted, because I believe that you guys know how this type of bulb works. We just heat the tungsten filament to a very at an extreme high temperature, and you can feel the heat around this type of bulb. So you may realize that much of the energy is wasted. Okay. Uh, okay. So we need some light sources that is more eco-friendly and where we can make the maximum amount of the use of the electricity. So there are these are the scientists, and thanks to them to discover, or you can say to make it possible to have a white LED that I think most of the places you have white LEDs nowadays. And I'll just talk about a few words how white LED works maybe. And uh, 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 basic, uh, basically their contribution, if you search their contribution is in the development of blue LED. And till that time there was no sources for blue LEDs, because if you have observed the spectrum, the blue light comes about around in this range of nanometer, like around 400 to 450 or 460 maybe. So it belongs to a very higher it belongs to bit higher energy. So we need some material that has a direct that has a wide band gap. And there was a material gallium nitride, but it was very difficult to grow it on a substrate. So I hope you know the concept of substrate and the layer to grow. Can I get a quick yes or no, maybe? Hello? Hello? Uh, Hello?
Dear student, you can unmute and tell.
Yes, sir.
No? Okay, no problem. I can just take a minute to maybe to explain what the concept of a substrate is, and how uh, and why we use that. Maybe just give me a second. Okay. So can you observe this slide of mine? So sapphire is basically a substrate which is very plain. Okay, it is a very flat substrate. And the role of a substrate is to support the growth, or to support the layer which will grow on it. Like this is a sapphire and there is gallium nitride which is grown on it by either by evaporation method, or maybe advanced method like molecular beam epitaxy. I hope you have not heard about molecular beam epitaxy, because it is very advanced method to grow semiconductor materials. But basically the role of a substrate is to support the growth of layers above it. So it is so it at that time it was very difficult to grow gallium nitride on any kind of substrate at that time, because there are the one of the problems you can observe here in this slide is that you can see these are like some cuts, something like that. Can you observe these cuts?
Yes, sir.
Yes, we call these cuts as defects, and if there are more number of defects, then we can't achieve a good type of LED, because much of the light is wasted due to this type of defects. So these scientists, these are the Japanese scientists, they took their time, they invested a lot of their time and energy to grow a perfect gallium nitride. Not very perfect, but gallium nitride which can emit at least light, uh, uh, and on a sapphire substrate. And this is bit in French, so I can make you understand. This is the sapphire substrate. If you can look at the pointer of mine, and here is the N type of gallium nitride, and there is a P type of gallium nitride here. And if you know the okay, just a second. So basically in a LED, there are three regions, P type and N type. The N type has excess of electrons with negative charges. There are P type with excess of holes that has positive charges. And when you forward bias the diode, like when you connect the positive terminal of the battery to the P-type region and negative type of the battery to the N-type region, the electrons and the holes, they move in the opposite direction, and finally they recombine at the active region, the region where you intend to recombine the इलेक्ट्रॉन्स एंड दी होल्स. जहाँ पे इलेक्ट्रॉन्स और होल्स रिकम्बाइन होते हैं, वो रीजन पर्पसली हम लोग उस तरह से इंजीनियर करते हैं, या तो वो नॉर्मल पीएन जंक्शन होता है, या फिर वो क्वांटम वेल्स होता है, या फिर वो क्वांटम डॉट्स होता है बेसिकली. और जब इनका रिकॉम्बिनेशन होता है, ये लाइट एमिट करते हैं. सो अभी जैसे मैंने बताया कि गैलियम नाइट्राइड जो है, ये ये वाले रीजन में लाइट एमिट करेगा, तो ये यूजुअली ब्लू रीजन है. बट हमें कौन सा लाइट चाहिए? हेलो, हेलो, am I audible?
Yes, yes.
Yes.
Yes,
So
sir.
yes, like हमें we are more interested in the white light, but the gallium nitride LED, it will emit blue kind of light, right? Hello.
Yes, sir.
Yes. So we need something. So there is a very thin layer of another material that we usually call it as phosphor. It is not the element of phosphorus. We call it as phosphor. It is a yellow kind of material. It is a yellow material. And uh, जब ये येलो मटेरियल गैलियम नाइट्राइड के ऊपर कोट किया जाता है, तो वो जो ब्लू लाइट होता है, ये जो ब्लू लाइट है, it gets absorbed, or maybe it gets absorbed, and there are other stuffs going on inside this material. And ये जो ब्लू लाइट जो है, ये इवेंचुअली शिफ्ट होता है लोअर एनर्जी की तरफ, और ये कॉम्बिनेशन ऑफ लाइट, कहीं पे रेड है, कहीं पे ग्रीन है, कहीं पे येलो है, सो इट प्रोड्यूसेस व्हाइट लाइट. एंड द एडवांटेज ऑफ एलईडी इज दैट यहाँ पे जो लाइट प्रोड्यूस हो रहा है, जो ब्लू रीजन में जो लाइट प्रोड्यूस हो रहा है, उसे आप वो ऑलमोस्ट सारे लाइट्स को आप एफिशिएंटली विजिबल रीजन में एमिट करा सकते हो. जबकि अगर मैं इन टाइप ये इनकैंडेसेंट लाइट्स या हैलोजन लैंप्स की बात करूं, तो ये ज्यादातर एनर्जी जो है वो आईआर रीजन में एमिट करते हैं, क्योंकि वो जो हीट एनर्जी होता है उसे हम लोग इंफ्रारेड, वो इंफ्रारेड रीजन में लाई करता है. दैट इज अबाउ 800 नैनोमीटर. एंड अबाउट 800 नैनोमीटर हमें कुछ दिखाई नहीं देता, so they are of no use for us. So this is why the LED emission in visible, like they have 100 पर, like जो भी लाइट एमिट हो रहा है उसे आप पूरी तरह से विजिबल रीजन में कन्वर्ट करा सकते हो. जबकि इनकैंडेसेंट लाइट्स में 10% ऑफ लाइट आपका विजिबल रीजन में होता है, और बाकी का जो आपका 90% रहता है वो थर्मल रेडिएशन, यानी कि वो आईआर रीजन में एमिट होता है. सो आपका मैक्सिमम एनर्जी जो है वेस्ट होता है. सो एलईडी के वजह से आप 70% एनर्जी रफली आप सेव करने की कोशिश करते हो. सो आई थिंक, बट एटलीस्ट आप लोग ने ये तो सुना होगा कि अभी ज्यादातर लोग इनकैंडेसेंट लाइट्स या फिर जो बल्ब्स जो है उसके ऑल्टरनेटिव्स में अभी एलईडी ज्यादा प्रेफर करते हैं, क्योंकि वो ज्यादा ब्राइट होता है और मे बी उससे लाइट बिल पे भी बहुत ज्यादा इफेक्ट पड़ता है। मे बी हैव यू हर्ड अबाउट दिस थिंग्स? Maybe you can quickly say yes or no, any one of you, if you have experienced. Hello. Okay. ओके, बट मेन रीजन यही है कि एलईडी से हम मैक्सिमम अमाउंट ऑफ एनर्जी यूज कर सकते हैं, बिकॉज हम ऑलमोस्ट सारे लाइट्स को विजिबल रीजन में एमिट कराते हैं। और बल्ब्स में हम लोग 90% ऑफ जो एमिटेड लाइट है उसे हम वो हम बेसिकली वेस्ट करते हैं, वो किसी काम का नहीं होता, क्योंकि वो आईआर रीजन में होता है लोअर एनर्जी की तरफ, और उसे अप कन्वर्जन कराना भी बहुत ज़्यादा एक्सपेंसिव हो जाता है और उसका एफिशिएंसी भी बहुत कम है। सो इसीलिए सो आई कैन शो यू द ब्लू एलईडी विच वी हैड डिजाइंड इन क्रेया। Okay, bye. Just a second. I'm sorry for my laptop.
No, no problem.
तो एक्चुअली आने क्या है, झापड़ा में बता, हम लोग के न्योता देके उनको बुलाएंगे।
Hello.
Yes.
Okay, okay. Yes, sorry. Yes. So this is a gallium nitride LED which we जो हमने क्रिया में ग्रो किया था। यहाँ पे जो यूनिवर्सिटी क्रिया में बेसिकली मैं इंटर्नशिप कर रहा हूँ फिलहाल, अपना मास्टर इंटर्नशिप। सो माय रोल इज टू ग्रो UV LEDs and other type of LEDs, and this is one of the result which I was interested to display, because this is just a schematic and I wanted to show you something which I already had regarding gallium nitride। and just ये देखो, ये आपका जो है ये ब्लू लाइट एमिट कर रहा है, जैसे मैंने कहा था कि गैलियम नाइट्राइड एलईडीज जो है वो ब्लू लाइट एमिट करते हैं। और यहाँ पे ब्लू लाइट एमिट कर रहा है, और अगर इसके ऊपर अगर फॉस्फोर का कोटिंग रहा तो ये व्हाइट लाइट एमिट करेगा, बट मेरे केस में देर इज नो कोटिंग ऑफ फॉस्फोर, जस्ट डायरेक्ट कॉन्टैक्ट। So, and this is the MB system at CREA on which we are working and we are using to grow the LEDs. So LEDs और सेमीकंडक्टर्स, आई थिंक ये मतलब ये टॉपिक को ज़रा सा होल्ड पे रखिए और हम इस पे फिर से वापस आते हैं। बट मैं एक और बहुत ही मेरा फेवरेट टॉपिक है और मैं उस पर थोड़ा सा बात करना चाहूँगा, दैट इज 2D मटीरियल्स। हैव यू हर्ड ऑफ 2 dimensional materials, anyone of you before? Maybe graphene, maybe have you heard about that? Hello. Hello, hello.
Dear student, you can unmute and tell.
Yeah, if there is no, you can say no. If there is yes, you can say yes. There is no problem.
Or you can
No,
you can
sir.
write in chat box. We will check.
Yeah, yeah. So the discovery of 2D materials is a very beautiful thing because there were two scientists, Novoselo and Jenin. They were experimenting something in their lab with the आपको स्कॉच टेप पता होगा ना, जो हम लोग ये जो स्कॉच टेप है यहाँ पे ये वाले डायग्राम में. सो देवर यू मतलब वो लोग स्कॉच टेप के साथ खेल रहे थे, और जो पेंसिल का जो लेड होता है, आई होप यू ऑल नो, द लेड ऑफ द पेंसिल इज मेड ऑफ ग्रेफाइट, विच इज एन एलोट्रोप ऑफ कार्बन. सो ये लोग पेंसिल का जो ग्रेफाइट है उसके साथ खेल रहे थे स्कॉच टेप पे लगाकर, और उसे बार 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 पील कर रहे थे. और उन्होंने एक चीज नोटिस किया कि जितनी बार वो लोग पील करते जाते हैं ये ग्रेफाइट के लेयर को, ये लोग उसको उतना ही थिन बनाते जा रहे हैं, उतना ही थिन बनाते जा रहे हैं. और जब इस चीज को उन्होंने ऑब्जर्व किया ऑप्टिकल माइक्रोस्कोप में, और फिर बाद में रामन मतलब अदर स्पेक्ट्रोस्कोपी, बाद में उनको पता चला कि जस्ट peeling with the scotch tape they have reached the thickness of atomic layer, like a monolayer, that is a single atom in like a sheet of a single atom. That's why these materials are called as 2D materials or van der Waal materials as well, because ये जो layers है इनके बीच में बहुत ही वीक फोर्स है जिसे हम वैंडर वॉल्स फोर्स कहते हैं. और आप मैकेनिकल फोर्स लगाओगे जैसे स्कॉच टेप से अगर आप पील करोगे, सो इट इज पॉसिबल दैट you can peel a monolayer or a sheet of atom, and you can fabricate a device out of it. And this is how most of the people are still using this method, that is peeling with the scotch tape. Still lots of people are using. And this is one of the project which I was doing in the laboratory of IIT Bombay. And you can see this is the optical image, and you can see the monolayer graphene. Maybe it is very thin, like it is almost transparent to observe. So but it is possible that you can achieve this result. Uh, and the discovery of this graphene in 2004 led to a very new branch of science of 2D materials. उसके बाद मानो कि एक नया यूनिवर्स का दरवाजा ही खुल गया 2D मटेरियल्स के लिए. बिकॉज ग्राफीन जो है बेसिकली, अगर आपको पता होगा तो ग्राफाइट जो है वो गुड कंडक्टर ऑफ हीट एंड इलेक्ट्रिसिटी है. एंड ग्राफीन क्योंकि मोनोलेयर है ग्राफाइट का, इट इज ऑल्सो वेरी गुड कंडक्टर. And people were more interested in investigating different kind of 2D materials, like which are semiconductors, which are insulators as well. And they found, like, the discovery led to the application in supercapacitor, solar cells, batteries, interconnects, flexible type of displays, like many thing. मतलब 2004 के बाद वो एक नया यूनिवर्स ही खुल गया. और ये 2D मटेरियल्स का एक और बहुत खूबसूरत चीज ये है कि जैसे अभी यहाँ पे कुछ लेयर्स है, मान लो कि यहाँ पे 10 लेयर्स है, और इनको मैं अगर पील करता जाऊँ और मैं कम करता जाऊँ, जैसे मेरे पास सिंगल लेयर है, जैसे ये वाले डायग्राम में, ये वाले स्कीमेटिक में, जैसे यहाँ पे एक मोनो लेयर है, यहाँ पे बाई लेयर है, 2 लेयर है, यहाँ पे 3 लेयर है, यहाँ पे 4 लेयर है. ईच लेयर्स का जो प्रॉपर्टीज है वो डिफरेंट है. जैसे अगर मैं आपको ये वाला इमेज दिखाऊं तो ये है डेटा मोलिब्डेनम डाइसल्फाइड का, जहाँ पे अगर आप मोनोलेयर को देखो, ये बेसिकली ये फोटोल्यूमिनेसेंस एमिशन का डेटा है, यानी कि सॉरी Okay,
You can proceed.
यस यस सो मतलब अगर एकदम बेसिक टर्म्स में अगर बताऊं मैं, तो जो मोनोलेयर जो है वो डायरेक्ट बैंड गैप टाइप ऑफ है, और जैसे जैसे आपका लेयर्स बढ़ता जाएगा, वो आपका मटेरियल जो सेम मटेरियल है मोलिब्डेनम डाइसल्फाइड, वो आपका ट्रांजिशन होते जाएगा इनडायरेक्ट बैंड गैप में, जहाँ पे वो लाइट बिल्कुल एमिट नहीं करेगा। सो ये जो पीक आपको दिख रहा है, ये लाइट का इंटेंसिटी का पीक है, और ये एनर्जी, और जो एक्स एक्सिस पे जो है वो कितना एनर्जी रेडिएट कर रहा है। सो जो मोनोलेयर है वो बहुत ही ज़्यादा हाई एनर्जी लाइट एमिट कर रहा है, और उसके बाद जब हम 3 लेयर्स पे आते हैं तो वो कम लाइट एमिट कर रहा है, और जब हम लोग 6 लेयर्स पे आते हैं तो ऑलमोस्ट लाइट एमिट ही नहीं कर रहा है, यानी कि वो ट्रांजिशन कर रहा है डायरेक्ट बैंड गैप से इनडायरेक्ट बैंड गैप में। जैसे हमने पहले पढ़ा था, डायरेक्ट बैंड गैप वो मटेरियल होता है जो लाइट एमिट करता है, और इनडायरेक्ट बैंड गैप वो मटेरियल, वो सेमीकंडक्टर मटेरियल्स होता है जो लाइट एमिट नहीं करता। So these are like, this is one of the very beautiful property that you can exploit to design your materials, maybe a monolayer thin. So yes, and using 2D materials, it is possible to design devices that is very thin, like the atomic layer thin. So if you see this gallium nitride, maybe it is very bulk, it is not a monolayer, and you can make more compact devices using 2D materials. And this is one of the very beautiful thing. You can make them emit light, you can design transistor based on different thicknesses of the 2D materials, maybe like डिवाइस फैब्रिकेशन आप और ज़्यादा कॉम्पैक्ट कर सकते हो। यानी कि जैसे हमने स्टार्टिंग में डिस्कस किया था कि मूर्स लॉ को जैसे मूर्स लॉ क्या है कि एवरी 2 years आपको नंबर ऑफ ट्रांजिस्टर्स या फिर नंबर ऑफ डिवाइसेस इन इंटीग्रेटेड सर्किट्स आपको डबल करते जाना है। बट जो एग्जिस्टिंग मटेरियल्स है, सिलिकॉन, जर्मेनियम, सिलिकॉन कार्बाइड, गैलियम नाइट्राइड, इनसे इनका एक डिसएडवांटेज है कि ये थोड़े बल्क होते हैं और इनके और भी इफेक्ट्स है। सो हम लोग मे बी वो ये ट्रेंड जो है वो मेंटेन नहीं कर पाएंगे इन मटेरियल से। सो 2D मटेरियल्स जो है ये ट्रेंड को बरकरार रखने में बहुत हेल्पफुल रहेगा, क्योंकि यहाँ पे हमने यहाँ पे मतलब बहुत बेसिक रिसर्च दिखाया है कि यहाँ पे एटॉमिकली थिन डिवाइसेस हम फैब्रिकेट कर सकते हैं। मे बी इंटीग्रेशन में टाइम लगेगा, बट वी कैनॉट से दैट इट इज नॉट पॉसिबल। And as I said that we are living from UV, we are living from LED, and we switch to 2D materials. But I want you to take back to this is one of our recent work we did in Korea, that we grew the LED, यानी कि जो LED स्ट्रक्चर है उसको हमने एक 2D मटेरियल, एक HBN पे हमने उसे ग्रो किया, और जब हमने उसे फॉरवर्ड बायस किया, यानी कि पॉजिटिव पी रीजन पे जब हमने पॉजिटिव वोल्टेज दिया और एन रीजन पे हमने नेगेटिव वोल्टेज दिया, और यहाँ पे हमारा जो एक्टिव रीजन है ये बेसिकली हमारा क्वांटम डॉट्स है। बट मैं इसके डिटेल में अभी नहीं जाना चाहता, मैं बस अपना रिजल्ट कम्युनिकेट करना चाहता हूँ। एंड जब ये इलेक्ट्रॉन्स और होल्स ये वाले रीजन में रिकम्बाइन होते हैं तो लाइट एमिट करता है, और ये UV लाइट एमिट कर रहा था around 270 nanometer, and this is what we expected because our targeted application was sterilization and water purification, जिसके लिए हमें एक लाइट सोर्स चाहिए था जो around 270 nanometer में लाइट एमिट करता है। And I think very few papers or very few results are available that growth of device on a 2D material, and we were happy to communicate this result for a conference last week in Taiwan. This was an international conference. So like this is also possible where you can integrate the 2D materials and the nitrides or other semiconductors, and you can make many things out of it. So
Sankesh,
yes, sir.
can you just touch on what are the different instruments
Yeah.
used for preparation as well as characterization of such type of material, if possible?
Okay. I can just a second. Mm, I didn't put in this slide, but I have another slide in which I have what are the what characterization techniques I had used to do this. So maybe okay. I think this will explain my results better. ओके, सो ये जो ये यहाँ पे ये एलईडी स्ट्रक्चर समझ में आया कि यहाँ पे हम एक रीजन पे हम पॉजिटिव कांटेक्ट पॉजिटिव और नेगेटिव कांटेक्ट हम बनाते हैं प्रोब्स को यूज करके, जो कि एक इंडियम प्रोब होता है जो कुछ इस तरह से दिखता है। ओके, और जब हम करंट को इंजेक्ट करते हैं इन रीजन में तो इलेक्ट्रॉन्स और होल्स रिकम्बाइन होकर लाइट एमिट करेगा, और ये लाइट को जो है हम कलेक्ट करते हैं ऑप्टिकल फाइबर से, और ये ऑप्टिकल फाइबर जो है इट इज फर्दर कनेक्टेड टू अ स्पेक्ट्रोमीटर। सो इस तरह से हम हमारा जो लाइट एमिट होता है इसे हम कलेक्ट करके हम उसको स्टडी कर सकते हैं कि ये कितने वेवलेंथ पे एमिट कर रहा है, इसकी इंटेंसिटी कितनी है, और कोई और लाइट भी एमिट हो रहा है क्या, क्योंकि कभी कभी ऐसा होता है कि नॉट ओनली one peak, but there may be several other peaks as well. And one more characterization technique which I use, you see, जब मैं कह रहा था कि quantum dots formation होता है, तो ये quantum dots को हम लोग किस तरह से स्टडी कर सकते हैं, ये एक और टेक्निक है जिसे हम एटॉमिक फोर्स माइक्रोस्कोपी कहते हैं, और हम एटॉमिक फोर्स माइक्रोस्कोपी से हम स्टडी कर सकते हैं कि हमारा क्वांटम डॉट्स का हाइट कितना है, उसका रेडियस कितना है, और यस हम लोग ये स्टडी कर सकते हैं उसका मॉर्फोलॉजी कैसा है, और ये मॉर्फोलॉजी के वजह से लाइट के एमिशन पे क्या इम्पैक्ट पड़ेगा ये हम स्टडी करते हैं। ये हम स्टडी कर सकते हैं इलेक्ट्रोलुमिनेसेंस से। सो बेसिकली जो जब हम करंट को इंजेक्ट करते हैं और इलेक्ट्रॉन्स और होल जब रिकम्बाइन होता है एक्टिव रीजन में, और जो लाइट एमिट होता है इस प्रॉपर्टी इलेक्ट्रोलुमिनेसेंस, सो हम लोग क्वांटम डॉट्स का इफेक्ट क्या है इलेक्ट्रोलुमिनेसेंस प्रॉपर्टी में, हम इसका भी स्टडी कर सकते हैं ये सेटअप को यूज करके। और देर आर अदर कैरेक्टराइजेशन टेक्निक्स ऑल्सो वेर वी स्टडी द क्वालिटी ऑफ द लेयर्स दैट वी ग्रो। जैसे ये HBN के ऊपर जो एल्यूमिनियम नाइट्राइड है, उसके बाद एल्यूमिनियम गैलियम नाइट्राइड है, इसका क्वालिटी कैसा है, इसका क्रिस्टल क्वालिटी कैसा है, इसको हम लोग स्टडी करते हैं एक्स रे डाइफ्रैक्शन को यूज करके। सो देर आर डिफरेंट टेक्निक्स विच we use to characterize our LED structure at each step. At each step we characterize and then we proceed forward. And I think I was on my last slide right now, and the takeaway message from today's session is that we understood the importance of semiconductor materials in our day-to-day life, and as a students of physics, we can find where we fit in this industry to contribute. Maybe you can go into research, or you can go into uh, industries where you can contribute your best to fit in this fit in the uh, in this industry, maybe, or in this era where you can prove that you have a very distinct contribution. And I hope you have understood something regarding why semiconductor is important, and you may have some idea where you can interest yourself the most. And if you want to start with some basic things to understand what nanotechnology is, or how, why, and why there is so much about nano today, then you can start with some a very basic lecture of this is very favorite lecture of mine by Richard Feynman on YouTube. And there is one more textbook of Sulba Kulkarni, nanotechnology and practices. And this is also like very for the very basic start. This is also, I find, a very good thing. And thank you for your presence and your time. And now I would like to talk about how many you like now we can, I think we can communicate. And I just want to know how many of you people are interested in research, maybe, or you are interested in higher studies where you want to go into some kind of industry, maybe. Hello.
Hello, student. Please respond.
Now I think we can communicate, maybe.
Yes, dear student, if you have any query, कुछ doubts है, then you can raise. Now session is open for question and answer. Sankesh, can you
Yes.
focus what are the different opportunities,
Yes.
job opportunities for our physics students, or
Yes.
not only physics, science students
Yes.
in foreign countries like France, then USA, Germany,
Yeah.
and what are the basic uh, basic steps for that to get admission in foreign
Yeah.
countries or with good step?
Thank you, Milind sir, for this question. And I would like to talk about this because we have students of BSc today with us, and I have shortlisted like some of the very famous scholarships that you can try for your masters, maybe. There is one called DAAD by Germany. I can quickly write it in uh, the chat, and I will further talk about this. And there is Eiffel Excellence Scholarship, for which I had applied, and I got selected. And this is for the France Eiffel
Sankesh,
Excellence.
congratulations, heartiest congratulations from our side.
I would like Thank you so much, sir. And I would like to thank Milind sir because for this prestigious scholarship, I requested Milind sir for his recommendation, and he provided me his recommendation, and it was very helpful for me to secure this scholarship during my masters. And there are other scholarships like Charpak. Maybe you can search regarding this. There are, you can have you can study are different types of Charpak scholarships for masters, for bachelors, for maybe lab exchange, and there is one more famous is Erasmus Mundus. And the advantage, what I want, these are the very famous scholarships in the European countries. Erasmus is like for the European countries, Eiffel Excellence and Charpak is for France, and DAD is for Germany. And these are the scholarships where you can try to apply for some master's program in these countries, and you can try to secure the scholarship. And the second thing is the advantage I would like to talk about when you go abroad for higher studies is that you get different kind of environment, and you get access to most of the things like at a very early age. Like see, I'm still doing my masters, and I can access AFM, XRD, electroluminescence, hall measurements, MBE. And it like MBE is very rarely found in many. It is very sophisticated instrument. It is very rarely found, and no one, even if one has, they will not allow you to use or touch the MB system very often. And like I'm talking about my system, but the opportunity is that there are many industries related to energy storage, related to semiconductors, related to photonics, related to quantum technologies, where after your masters you can get your job easily. And uh, even if you are in your bachelor's, then it's difficult to secure a job right after your bachelor's. Maybe you can plan for master studies, and then you can enter into these industries in these countries. And the second thing is, since you are in bachelor's, I would like to uh, uh, say that I would like to advise that you can join for some internships at IITs or IISc or ISERs maybe during your summer vacation. And there are lots of opportunities by these. Just we have to be aware about those. Or you can maybe write a mail to the professors of these institutions. You can just write about yourself. You can prepare your CV, and you can prepare your mark sheets, and you can write about yourself and your interests. And you may work in their laboratories, and you can experience many things that are very different, because in IITs they mostly talk about like in a laboratory, in a discussion, or maybe during a conference. There are people who are very, you will find they are very dedicated in these fields, and you will get a lot of information from these people which you may not even find in the internet. So if your plan is to go for higher studies, or maybe for a job opportunity in European countries, it's bit I will say not difficult. It's bit competitive, because there are many people, many students who want to travel to these countries for their higher studies and job opportunities. So you have to make your CV distinct. And how can you make your CV strong? By first of all, the basic thing they look for is your academic grades, and it matters a lot, like how you have performed in your previous uh, uh, during your previous studies, like yeah, in your 12th standard. Sometimes they ask for your 10th standard as well, and they observe the CGPA from each and every semester, like how consistent student you are. So it should be, your consistency should be reflected in your CV. And this is the first thing. And the second thing is, how to make your CV stronger uh, is by gaining experiences. Because when you try to go abroad, they look not only at your CV and your grades, but they also want to look at, they also see how committed you are to the work which you want to join in. So you can show your commitment by your corrective experience. Maybe, for example, if you want to go for some master's program that is related to, for example, mine is related to nanophotonics. So I have to have a corrective experience that is related to this branch from my previous years, so that I can prove my commitment to this course. And this is how you can build your CV. And the only thing that mostly matters is your CV and your commitment and your communication skills. And those are very important, because you may be a very good student, you may be a very bright student, but sometimes it happens that during the communication, people may feel anxiety, or they may feel some kind of pressure, or they may sometimes it is not very easy to communicate their ideas to the people. So it happens because we lack somewhere practices. So the only advice I would like to give you to improve your communication skills is, please talk to your teachers most often, because it will help you a lot to boost your confidence and your communication skills. Because when you are talking, for example, when I was doing my bachelor's, I most often used to talk with Milind sir, Namrata ma'am, Poonam ma'am, Seema ma'am, Steffi ma'am, Lakshman sir, everyone. Because it's somewhere like I used to feel like it somewhere it is improving my communication skills, uh, like by practicing. Like you have to be efficient enough to communicate your ideas in your words. You must be able to communicate your commitment with your words. You may have to bring other people in your confidence. So you can just secure some you can secure the thing, like if it is a job position, if it is a maybe masters or PhD program, then. And if you want to plan directly for your PhD after your masters, then I would say it will become bit highly competitive as compared to masters. Because for the PhD, in Europe, there is a culture that people have a lot of internships and lot of experience. Because even in the master's program, like in almost all the master's program or bachelor's program, their last semester, like the semester 6 or the semester 4, is completely dedicated to internships. And in between, they have short-term projects, and so they have a lot of collective experience as compared to us. Maybe if we are if we directly want to go to PhD, either if you want to go to PhD, then you should have a paper maybe, or you should have worked with a very good laboratory, maybe in some IITs, or in some maybe in some IITs or ICERs or IISc. The overall thing is it is possible to secure, but the only thing is you have to build your CV from now. Like it is not possible to build your CV when you want that position. You have to build your CV from right now, like where do you want to land, and it totally depends like what is your interest. So this is all what I want to say, that uh, it is possible, but the only thing is you have to commit to what you say. uh, so yeah, so anyone wants to talk or maybe want to ask or regarding today's session, or maybe my experience? Yes, and I would also like to say that today in this conversation there is Satish Gupta, and he is my friend, and we were classmates during our bachelor's, and he also secured a Eiffel Scholarship for master's program in France for the year 2024. And I would like to congratulate Satish Gupta. And again, I
Satish,
would
congratulations.
and
Satish,
again
congratulations.
Thank you
I
so much,
would
sir. Thank you so much,
I
sir.
would I would like to also thank Milind sir, because he provided a recommendation for Satish to secure this prestigious scholarship. So thank you, Milind sir, again from my
Most
side.
welcome. Most welcome.
So I think from my side, I am like I don't have words more to talk about more. Maybe if the students want to interact or they want to ask something, then they may can.
Yes, yes, yes. Shifa, Aryan Naik, Ayan Sheikh, Divyanshi, Jivesh, Mudika, Nupur, Priya, Pooja, Rita,
Yes, good
Sin,
afternoon, Milen sir. How are you?
Isra,
Anand Shetty
और
here.
आनंद सर welcome. If you
देखो
have
मैं
any,
I
बोलो
am
बोलो सर.
I am also watching it, but then वो कैमरा ओपन नहीं दिख रहा है मेरे को. But anyway,
I will give permission. You can start your video.
Yes, I think yes. Hello आनंद सर, हम पहले मिले हैं बट बहुत कम बातें हुई हमारी, क्योंकि मेरा कॉम्बिनेशन फिजिक्स मैथमेटिक्स और स्टैटिस्टिक्स था. सो
नहीं, आनंद सर मिलने के बाद तेरा कम्युनिकेशन कम होता है और सर ही ज्यादा बोलते हैं. बराबर है सर. यस सर.
आनंद सर आप म्यूटेड हो.
सर अनम्यूट करो. यू कैन. आनंद सर प्लीज अनम्यूट एंड यू कैन
हाँ
स्पीक.
हाँ तो संकेश is our BSc physics students.
Yes,
Yes.
FY BSc in physics, maths, stats, then SY in physics, maths, and then BSc physics student.
Okay, and MSc now you're doing or finished?
I completed my MSc from Nanoscience department in Mumbai University, and last year I again applied for an integrated PhD course, that is Masters and PhD in France in University of Troyes. So I am still doing my masters. I will complete in this July. I am doing my master internship right now, and further from the October I will start my PhD.
Very good, very good. So nanoscience में when you are doing at Kalina campus, no?
Yes, yes, yes.
So your director was Dr. Santosh Sharan that time.
No, my director was during my first year. It was Dr. Samir Kulkarni, and when I was in the second year, it was Professor Garje from chemistry department, and I
Right,
think now it is Dr. Vishwanath Patil.
right,
And
right.
during my masters in my semester 3, my professor was Dr. Suhas Jejurikar, and for my semester 4 I just I got an opportunity to do internship at IIT Bombay. I think this is, I would like to talk about this opportunity for our bachelor student, maybe for our masters, because each year the IIT Bombay, they provide it is a national scheme where students from last year of bachelor's and last year of masters, they can apply for an internship for 6 months, and they have to submit their mark sheets, they have to write their motivation for the project which they are applying for, and they can, if they get shortlisted for the first round, then they will be interviewed by the project investigator, and then if they are further selected, then there are like almost every year there are like only 60 students selected for this internship, but it is a very good opportunity to explore and to have hands-on experiences with different advanced instruments and this is how I got landed into IIT Bombay. And then like I explored more things, and nanophotonics, it came into my picture with respect to Dr. Suhas Jejurikar, and then we proceeded to the scholarship, and we are doing good now. Like it was a very good opportunity. So I just want to communicate this opportunity so that you can communicate for your students maybe.
So when you come back to India, I want you to meet me where I can make one video with you. But basically the message which I also want to give to the students after teaching for nearly 35 years. I have been teaching in National College for 35 years as a chemistry faculty, and I'm a postgraduate from IIT Mumbai. And today I had my MSc friend who is a faculty from US who also met me today. That is material science, how we have grown in the last 40 years. That is, if
Sir,
we had to...
sir, Anand sir, he's from forensics background.
Forensic, huh? But basically the title was material science, na? So that is what I was interested in, material science or whatever.
Okay.
Yes.
But क्या है, मुद्दा क्या है? In the last 40 years, if I had to get this smartphone manufactured, it would have weighed at least more than a ton.
Yes.
And it would have been more than 14 meters in height, and it would have costed, one smartphone would have costed about $100 million.
Yes, I
But
agree.
in 40 years, we have developed so much in material science, then we can carry this smartphone in our pocket.
Yes.
But next 5 years, the growth in material science will be 10 times more than what it has taken place in the last 50 years. So we are in a very exciting phase. That is the message I want to give to the students.
Yes.
But for that, they will have to dive deep and get the fundamentals very strong.
Yes.
Right, Sankesh?
Yes, you are absolutely right. And one thing I'm sorry to miss about that is in the bachelor's course, that I think most of the students today who have joined are from bachelor's. And I think the faculties of National College, they are doing a very amazing job in forming a very strong foundation. If the students are very really interested in higher studies, and if they want to build a very strong fundamentals, then if they just concentrate on what the faculties are teaching right now, then they will build a very strong because the only time to study or to make strong our fundamentals is during our bachelor's, and after that during our master's there are so many things to study, so it becomes very complicated either to go back to the fundamentals again or to go to learn some advanced technologies. So if the students are focusing right now since their bachelor's in their studies, then I think it will be very advantageous, and especially for the students of National College, it is I think it is a very I think like for me, I think I was very lucky to get admitted in National College and study in with the faculties, because
Thank you, Sankesh. Thank you so much.
Thank you. Wish you all the best, Sankesh. And when you come back to India, meet me. I will gift you one special book. Okay?
Sure. I would like to meet you and receive your gift with
Yes.
and
And Congratulations, Milind sir. You are doing a great job.
Thank you, Anand sir. Thank you
Yes,
so
और
much.
इसको
absolutely.
YouTube में लिंक बना दो, इसको YouTube का लिंक बना दो ताकि स्टूडेंट्स कैन टेक द बेनिफिट.
Sure, sir. Sure.
Okay, चलो बाय
Yes.
God bless, bye.
Thank
Bye,
you,
bye.
sir. Bye.
Yes. Yes, Lakshman sir, Poonam ma'am, or
Thank you,
if you have
Sankesh.
any.
Thank you, sir. Thank you. अच्छा लगा.
Sankesh, thank you so much on behalf of the entire department. And we are extremely proud of you and Satish both, that you both have done amazing job. Even when you were in nationals, you were exceptional. And you'll have proved that time and again. And now getting these scholarships is not a small feat. So congratulations and all the best from all of us at nationals.
Thank you so much, ma'am, for your kind words. And it was like I'm happy to talk to you after a very long time. So thank you so much.
Yes, dear student, Yusra, Sen, Rita, Pooja, Nupur, Modika, Jivesh, Divyanshi, Ayan, Shifa, if you have any query. मोदिका भी तेरे सेम बैच ना?
Yes, I think in
मोदिका
T1,
सतीश, yes.
it was during the COVID, so we were
Yes.
online. Yeah.
Yes, Modika, if you have any query, you can raise. Yes, dear student, और कुछ आपको query है और any doubt clear करने का, you can clear. And after completion, we will share what are the different scholarships available as per.
Maybe I can in the same presentation I will add some slides regarding these
Okay.
scholarships, and I
Yes.
will send it to you. Like I will prepare. I will put some more information. I
Yes.
didn't honestly I didn't have the time to. I
No
wanted.
problem. But thank you so much for your valuable
Yeah,
time.
but I will do this thing and I will send it to you
Yes.
immediately. And
I think Sankesh, I think
yeah.
पिछले 1.5 साल से हम ट्राई कर रहे थे टू अरेंज योर लेक्चर.
Okay.
तो आज मुझे मतलब ये हुआ. नो प्रॉब्लम.
Yeah.
एंड थैंक यू सो मच फॉर योर वैल्यूएबल टाइम. इतना बिजी स्केड्यूल से तूने हमारे स्टूडेंट्स को गाइडेंस दिया. दैट इज द बेस्ट वे. And we will share your PPT with our student, and if there is any doubt or कुछ query है, so
Yeah.
they can directly contact with you
Yes, I
via
can.
email, and
Yeah.
I will share your email ID and all details with our student.
Yeah,
Then
sure.
they can directly contact you for your
Sure.
fruitful
No problem.
guidance. Okay.
No problem.
And yes, Poonam, can you proceed for a vote of thanks? Is Sima ma'am is there? Okay. No. Okay. Now I will. Yes. Yes, Poonam ma'am, can you? Dear student,
Yes,
if you have any. Okay.
so first of all, I would like to thank Sankesh obviously for taking the time out. Even when you're there, there's time difference. You have a hectic schedule. You're completing your masters. So still thank you, and thank you to Satish also for being there in the entire session. I'm sure he's also
Thank you.
just come there, so he has a lot of work on his plate. Also, I would like to thank our principal and our DBT coordinator for the DBT Star Status Scheme for giving us this opportunity. As
Namrata
always,
ma'am,
Dean
HOD.
sir.
Namrata ma'am, HOD.
Yes, coming. So Namrata ma'am
Okay.
and Dinesh sir, all our vice principals. So though Namrata ma'am is not here physically, but her support has always been there. So we are able to conduct these sessions. And especially to Milind sir for being so proactive always.
Thank you.
Before
Thank
we
you.
can even think, sir is already executing the plans. So whatever the department plans, it's on paper, and the next minute, sir is already ready with it. Lakshman sir, Seema ma'am, and everybody from the physics department, including our non-teaching, because obviously a lot of technical help is from them. And finally, our students for attending. However, we would also like you to be more proactive and ask more questions, because these opportunities are not going to come in your way like every day you are not going to get such opportunities. We will obviously try to arrange more lectures in various other fields, with field visits also. But every lecture, every field visit, every workshop you have to utilize to the max. Because Sankesh is free today after 1.5 years. So it is not going to be every day. Even if we share his email ID, this will be the best chance to speak to him. So
Correct,
we
correct.
would request you all, though it is very good and we are very grateful that you've attended, but also be more proactive. And once again, thank you so much, Sankesh. Hopefully, whenever you come down to India, we'll meet you again soon, and then we'll have a session offline, because
Yes.
offline
Yes,
definitely is quite more interactive compared to online. So
Yes.
thank you, and over to you, Milind sir.
yes. Also thankful, sincere thank towards Dr. Kiran Jathar ma'am, Vice Principal. Uh, then Mathematics Department, Anjana ma'am, Rajesh sir, and Stat. I think Stats के लिए कौन था संकेश
Uh,
जी?
Kailash Pandey, sir.
हाँ काले सर, डॉक्टर काले सर, ओके। तो उनका भी हम
Yes,
विल
yes. मैंने
थैंक्स टुवर्ड्स
मैंने उनको
मैथमेटिक्स।
कांटेक्ट किया था लास्ट ईयर, मैं जब यहाँ पे आया था तब।
ओके ओके,
So,
अभी सर बाहर है, अभी सर
जी
बाहर है।
जी जी।
This is.
And
So thank
please,
you. In future, dear student, now in the month of July, नहीं तो August में we are also arranging offline session. That is, what are the different opportunities in aviation industry by Director Vivek Kulkarni. कि जो एयरफोर्स में more than 15 years का उनका सर्विस है, and currently he is with aviation industry as a director. तो नेक्स्ट कम जुलाई में तो अगस्त में we will arrange different sessions, or that is which are related to our which for our science student. तो वो भी आप अटेंड करो। एंड अगेन डियर स्टूडेंट, थैंक यू सो मच फॉर योर वैल्यूएबल टाइम। एंड एक्सट्रीमली सॉरी मैंने आपका सेशन लंच टाइम पे रखा, लेकिन आप आपने अटेंड किया। थैंक यू एंड थैंक यू सो मच संकेश, थैंक यू सो
thank you,
मच,
sir. Thank you so
थैंक यू सो
much,
मच।
and please communicate my love and respect to
यस
Seva
यस
ma'am, Namrata ma'am, and Dinesh sir,
यस
and
यस यस
because and Poonam ma'am, thank you so much. It was very like it was very happy to hear you after a very long time, and I am eager to meet you when I will be in India, hopefully in the next year, maybe.
यस
If possible,
यस।
I will
और
definitely.
एक यस यस, और एक रिक्वेस्ट कर रहा हूँ कि संकेश, एक हम एक दिन ऐसा कुछ दैट दैट डिपेंड्स ऑन यू इफ पॉसिबल, एक
Yeah,
तेरे लैब का हम वर्चुअल बच्चों को वर्चुअल टूर करेंगे। मींस इन दैट वी विल ट्राई टू शो व्हाट आर द एमबी मोलिकुलर बीम इफोटोक्सी, देन एक्सरे डायफ्रैक्शन, मींस बिकॉज देयर आर डिफरेंट instruments, but quality type instrument, research grade instrument, if possible we will show virtual tour, and we will arrange one session in conference room ki with other what are the different high end appliances or instruments generally used for a high end study. So if possible, that is
okay.
our maybe future plan. And dear student, thank you so much, Shifa, Ayan, Divyanshi, Jivesh, then Mudika, Nupur, Pooja, Rita, सतीश तो अपना ही है, सीन, युशरा खान, देन आनंद सर, पूनम मैम, लक्ष्मण सर, सीमा मैम, एंड थैंक यू सो मच।
Thank you so much.
Now
Thank you so much.
thank you, and thank you so much Sankesh for your
Thank you.
valuable time. And dear student, now we will end this session, and thank you so much again. Thank you.
Always available for you, sir. You
Yes,
can just let me know, and
thank you.
on the Saturdays we can arrange. Thank you so
Yes,
much.
no problem. Sure.
Okay,
And
sir.
again, all the best for your bright future. Okay.
Thank you so
And
much.
for TY student, all the best for your future exams and your future same for assessment. Thank you all. Thank you so much.
Thank you,
Now
everyone.
we will end.
Have a nice
Thank
day. Bye.
you. Bye.
Thank you so much, sir.
अभी
Thank you.
कितने बजे है संकेश? अभी कितने बजे है उधर?
अभी 12 o'clock हो रहा है, sir.
Okay.
There is a
Okay.
time difference of 3.5 hours.
Okay. Yes.
Yes.
Thank you.
Okay, sir. Bye. Thank
Okay.
you.
Bye. Dear
Thank
student,
you,
thank you so much.
Sankesh. All the
Thank you,
best.
thank you,
ma'am.
thank you,
Thank
thank
you,
you.
ma'am. Bye. 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 Bye.
Bye.
Thank you.
Thank you. Thank you.